Assalamualaikum and hi. We are from Group 11 and we will talk about the magnetic particle inspection. In order to accomplish assessment by Professor Dr. Abdul Razak Ibrahim, we are assigned to detect a problem related to magnetic particle inspection and its solution. This is the members of Group 11 and we are representing a company with an outstanding customer service, 24/7 emergency test service, with fast response, which is Baker testing. Now, let's move to the introduction to see the background of Baker testing service. Hi, my name is Nur Alia Natasha Johari. My metric number is 141181. I will introduce to you about Baker Testing Company. Baker Testing was founded in 1979 and offers over 40 years of experience in the field of non-destructive testing, or we call NDT, and metallurgical analysis. In addition to field testing, laboratory testing is available in Rockland, Massachusetts, and Troutman at North Carolina for a wide variety of industrial NDT testing and destructive testing services. Baker Testing Services is an independent NDT laboratory providing consulting, analysis, and testing for structural reliability and in-service quality inspection. These are the services that are offered in Baker Testing and the industries they get involved in. Now, let me explain a bit about the industry's involvement. Firstly, Quality Bridge Inspection Service for both new construction and in-service bridge. Second, in-service inspection of pipes and tanks to prevent unexpected outage during peak seasons. Third, non-destructive testing inspection of welds and material thickness for in-service pipelines and new construction. Fourth, regular tank inspection to provide key information on maintenance for decision makers. Fifth, inspecting building steel and concrete for commercial and residential construction projects. 6. Surface or subsurface inspection to detect flaws in castings, forgings, and machine roll products. 7. X-ray of ashes and charred remains to assist investigators in locating forensic evidence. Next, identification of sculpture reconstruction methods and art materials using NDT inspection methods. Also, quality control and fire investigation using digital X-ray images. And finally, some additional applications taking advantage of NDT for quality inspections. In this video, we are discussing about a problem faced by a pipeline company and how Baker Testing helps to fix the problem by using magnetic particle testing. In the next slides, Anissa will explain the problem in detail. Carbon steel and other ferromagnetic piping and pipe welds are commonly tested for surface cracks and other flaws by magnetic particle testing. Some piping and weld configurations do not allow for radiography or ultrasonic testing, or they may not require those tests for code conformance. Magnetic testing is a rapid and effective method for flaw detection that can be done both at Baker Testing laboratories and in the field with several methods and indication sensitivities. The procedures will be explained in detail by Iziati and Huda in the solution part. Inspection services include longitudinal scans, X-ray of new pipes, and girth welds typical on hot reheat piping. So that's all from me. Thank you. Recently, the multinational largest pipeline company in Canada, which is Enbridge, has contacted Becker Testing to discuss the inspection and testing methods best suited for their project. Enbridge operates across North America and beyond, powering industry, empowering society, and safely delivering reliable, affordable sources of energy through their 4 core businesses, which are liquid pipelines, natural gas pipelines, gas distribution and storage, and also renewable energy. From the discussion, there are some defects occurred on the pipeline system. The defects are listed in the next slides.
Hi, my name is Nurainisa binti Abdul Jalil. Now I'm going to proceed the presentation with the problems that Enbridge company encounters. There are overall 3 of them. The first one is corrosion, the second one is denting, and the last one is wrinkle. In the first problem, it is related to the first 2 services, which is the liquid pipeline and natural gas pipeline. As you can see in the diagram, shows the corroded areas on the surface of a pipeline. So pipeline corrosion is the oxidization and electrochemical breakdown of a surface of a pipe used to convey any substances. This pipeline corrosion can occur both inside and outside of the pipeline, which is exposed to corrosive elements. Therefore, we require high resolution to capture of all of the corroded areas to identify whether the corrosion occurs whether internal or external or both. This is because there are a few types of corrosion. For example, like uniform corrosion and pitting corrosion. Pitting corrosion is the localized form of corrosion by which cavities or holes are produced in the material. This pitting corrosion have 2 more types, which is the through pits and the sideway pits, as you can see on the diagram below. This pitting corrosion is more dangerous than uniform corrosion damage because it is more difficult to detect, predict, and design against. Therefore, we need to identify the correct corrosion that occurs in our pipeline. In conclusion, we require the correct non-destructive testing that could extract the corrosion depth inside a pipe's mechanical damage. The next problem is the mechanical damage called denting. As you can see on the diagram below, this defect requires an automatic detection of depth maximum because the traditional measurement methods like the pit gauges can no longer do a good job in inspection functionalities. We require a fast measurements in any condition to enhance the analysis capabilities. Therefore, we require the most suitable non-destructive testing to detect the denting in our pipeline. The third and last problem that Enbridge company encounter is a mechanical damage called wrinkle. As you can see in the diagram, the wrinkle is defined as a localized deformation of the pipe wall. A good non-destructive testing must be able to measure the depth of the ripple, wavelength, circumferential extent, and diameter restriction accurately to analyze the problem effectively.
Hi, my name is Nurainisa binti and I will continue the presentation on the solution. Pipelines are inherently complex, so expecting them for damage, such as corrosion, rot, and atmosphere-induced cracking, and bends, can be extremely time-consuming. And in addition, the complexity of the pipeline geometry and unstable excavation environment can hinder the inspection team's ability to spot some further important information or damage. So what is the solution? The solution we use using the handheld 3D scanners, pipeline operators, asset owner, as well as NDT service provider can benefit from an easy-to-use, fast, and effective tools for all types of pipeline integrity inspection. This handheld scanner offers a complete 3D picture, which is with geometry, texture, and color, as well as integrated pipe check software. By using optical technology, 3D scanners generate highly accurate, repeatable, and reliable results with exceptional resolution and speed regardless of user ability. The corrosion monitoring and assessment of gas pipelines using 3D scanners. Few steps, which is first step 1 is initial inspection. An initial visual inspection highlighted multiple areas of corrosion under the pipe support, which is evident in the photo. Corrosion under support, CUS, as its name suggests, is corrosion that occurs at the interface between a metal component and the object that supports it. Support locations such as bracket and clamps tend to act as entrapment areas for water and other liquid that can result in corrosion. This type of corrosion is highly localized and can result in the formation of beads and other forms of corrosion damage. For step 2, which is cleaning and short blasting of pipe. Once the initial inspection was concluded, it was decided that the corrosion would require a more thorough investigation using a 3D scanner. Short blasting was required to prepare the surface for scanning with the added benefit of removing all the grease, rust, and scales. Short blasting is a form of abrasive cleaning which is primarily used for surface protection and preparation of a part such as a pipeline prior to applying a paint or a coating. Next, the process involved propelling abrasive materials at the surface of the metal pipe at extremely high pressure. Lastly, the short blasting cleans, strengthen, and polish the metal. It also allows any weaknesses to be identified and rectified by the asset owner or NDT service provider before applying any coating.
Scanning in pipe check is separated into two main operating principles, which are target acquisition and surface acquisition. The target acquisition is the most important step in regards to accuracy. The white targets allow the scanner to know where it is at all times and is therefore crucial to the accuracy of the scan. The surface acquisition is done using the lasers. The lasers are deformed by the surface and the cameras record that deformation to create the surface. The pipe check arrow allows the scan to be properly aligned and can be used to align the pipe to other types of data such as ILI and UT. It is usually placed at the 12 o'clock position, close to a girth weld, in order to properly reference it. It should be placed parallel to the pipe axis.
Assalamualaikum, my name is Nurulda. I'm going to continue the step solution that was presented by AZT. The next step is step 4, which is analyzing the data. Okay, what the things that we have to analyze is first code selection. Select between SME, P31G, or for depth analysis only. Second is SQL parameter. The flow state is used in the P31G, modified P31G, and effective area standard calculate the bursting pressure. It's vitally important to select the correct specification from beginning. The design vector specified minimal yield strength SMYS and pipe material grade are the most important value. It should be provided from the pipeline or asset owner prior to any analysis being carried out. Next is pressure parameter. The MOP, maximum allowable operating pressure, is the main pressure to which the burst pressure is compared, automatically calculated by the software according to Barlow's equation. The MOP, maximum operating pressure, is also an important value that should be provided to the inspection team by the asset owner. The next thing that we have to analyze is interaction parameter. Their shapes and size will vary depending on the interaction parameters. Critical factor percentage, which is depth, percentage of wall thickness at which a corrosion pit is deep enough to be evaluated and listed. Pressure and corroded area percentage is depth of percentage of wall thickness at which the corrosion feature dimension are measured and interaction rules are applied. Next, area and circumferential criteria. Each corroded area is delineated according to the selected interaction method at the depth defined by the threshold for corroded area. Delimited areas are enlarged by half as axial and circumferential criterion, which is red lines. Next, critical factor and pressure. A virtual pit gauge measurement is taken in every grid pixel based on the scale resolution set. The feature dimensions starts and end at the threshold depth value. Anomalies are combined into the cluster based on the interaction rules. The last step of this solution is step 5, which is result. All this data is then extracted into an Excel spreadsheet and a report is created for the client. This is some example of the data that we extract from the software and make available to our clients for reporting and filing purpose. As can be seen above, the data and analysis functions available to the pipeline engineers and asset owners are now endless. These are some of the extra benefits of using the pipe check software when compared with manual technique. The software's corrosion report function allows Excel report including worst case profiles and predicted failure paths, export to CSV available for further analysis, mesh export available, customizable paths or fail criteria, snapshot tools for 3D reporting. The software's then report function allows cross-section details, Azure and circumferential, CSV depth, grid export, mesh export available, Excel report with overlay measurement, diameter and calipers. The software Wrinkle reports function allows the Excel report with all standard information for Wrinkle analysis. That's all from us. Thank you.